All right. So we've looked at consistency level in isolation. Read separately, write separately. Why don't we put it all together and play a game? So our good old N2, N3 and N4, our 3 replica nodes. So what basically happens is, I have an application where I have a put operation at consistency level 1 and I have a get operation, select operation at consistency level 1 as well. Okay. So my application, there is an insert statement and there is a select statement in the same code, in the same function, same method, let's say. So now the question is, what behavior can I expect? So as we have seen already, when I say write consistency level 1, one replica node has to respond back, and asynchronously the data is reaching out to the other nodes. The coordinator has responded back to the client, job done. My read kicks in. Question is, what can I expect? I have two choices. It will either be B or A. There is no other third possibility. What is the likelihood of me getting the latest data? Here's the thing. Since the read consistency level is 1, I can potentially choose any of the nodes to read the data from. And it so turned out that the coordinator has chosen node N4 to read the data from. And N4 has not yet committed or received the data. It is responding back with the older data A. So here's the problem. I just inserted a credit in my user's savings account. And when I'm printing out the statement, it does not have that entry. This is exactly the classic situation. Or in an e-commerce company, I have an order. I just increase the number of items that I wanted to purchase. When I'm printing out the order status, I'm still showing the older one. So the odds are 1/3, given the fact that both reads and writes are responsible for one node apiece. Why don't I change the consistency level? And I can do that as a programmer. In my application code, I can change it and I can specify consistency level individually. So this time what I'm doing, replication factor remains constant. Write is 1, read is quorum. Please note, I am going to slow down the read, but write continues to be blazing fast. So what's going to happen? Naturally, again, one node has to respond back and I'm reading from quorum. What are the odds of me getting the latest data? 2/3. Think about it. In quorum, I chose N3 and N4 to read the data from. One of them gave the full data, the other one gave the digest. The data and the digest will match. No questions about that. And coordinator thinks, okay, yeah, this is the view of data, which is actually correct. But if the coordinator had chosen N2 and any of the other two nodes, N3 and N4, then I would have guaranteed gotten the new data. Yes, data replication is in progress. So consider a situation where N3 is getting the data as part of the replication, and suppose the coordinator had chosen N2 and N3 for the read repair will also happen. So that means N3 is going to get 2 copies of the same data. One as part of the original replication and second as part of the read repair. Do you think that's a problem for N3? Not at all. Because the data is going to be identical. We already talked about upsert. So one data is received, the other one is obviously upserted. Who cares? It's the exact same data, including the timestamp. So there's no problem there. So you noticed the moment I did read quorum, what happened is I slowed down by read. I paid the currency of time to increase my odds of getting the latest data to 2/3 from 1/3 in the previous combination. If I were to continue this and say replication factor is 3, write is 1, read is all. So what will happen now? Write is 1 and read, it's going to read from all the replica nodes, N4, N3 and N2. Of course, we do understand if any one of the one node is down, the data availability is not there. System is still available. So what's going to happen? I am going to get the latest data. Folks, a point to be noted here. All will consume the maximum amount of time. Is this not strongly consistent system? So if you really think about it, a masterless architecture, if I pay the currency of time, I can get strongly consistent system. I do have partition tolerance. Of course, not in this example, right? If one of the partition goes down, all will fail. So I do not have partition tolerance, but let's talk about consistency only for the moment. Do I not get strongly consistent? Absolutely. A blocking read repair is also a possibility. But guess what? This is the situation where the customer just deposited that check and I'm printing out. That printout contains the entry of that check. Now, why don't I flip the game? So far, what we've been doing is we've been penalizing the read. We've been slowing down the read. But write is working at blazing fast. Now, why don't we slow down the write and say, hey, write, you're going to do this in quorum. And read, by the way, you're going to do this in 1. Let's take a look what it has to, how it will turn out. N2, N3 and N4 as always. 2 nodes has to respond back, N2 and N3, that's good. Now if I read from 1, that node could be N4. That node definitely could be N4. I'm reading from 1. Remember, read, when I say read consistency level 1, it only reaches out to 1 node. So I could potentially get the stale data, but the odds of getting the latest data is 2/3. The odds of getting stale data is 1/3. So I paid the currency of time at the time of write to improve my chances of getting the latest data. And naturally, if I write all and read 1, as in the previous case where I basically wrote in 1 and read from all, again I'm going to get full consistency. Write in all the nodes and read from only 1. Guaranteed I'm going to get the data. And in that case, write pays the penalty of maximum time. Doesn't matter what I do, the currency is always time. And this is a tunable parameter in my application code. I don't have to bring any external system to address a shortcoming, as in the case with master-slave architecture, where if the master went down, until the secondary became master, I had to store the data in cache, a third component. I don't need that in here. You do realize with all I got a problem. No, not personally. Right, from an application perspective, there is a problem. And what is that? Data availability. If one replica goes down, I got a problem. So what if I gave you the combination of quorum? Let's not go all the way to all. If I write in quorum and I read in quorum, what do you think will happen? Let's take a look at the combinations. If I chose N2 and N3 to read from latest data, N2 and N4 to read the data from latest data, N3 and N4 to read from latest data. And the beauty of this combination is I can tolerate one replica node down. If N4 was down, I could move along, I could chug along without caring about whether N4 received the data or not, because I explicitly told, the client explicitly told the coordinator to operate at consistency level quorum. So what has happened is, now I have immediate consistency and partition tolerance. Obviously, system availability is a given because of masterless architecture. So this seems to be a fabulous combination when we are talking about getting immediate consistency and partition tolerance and availability. So I get all three attributes of CAP theorem at the price of paying the currency of time. So now you can clearly see that it appears as though one is blazing fast. It can tolerate maximum number of replica nodes down. If my replication factor was, let's say, 5, and if I wrote it in 1, I could not care about the remaining 4 nodes. They could very well be down. Maximum nodes down, blazing fast, but unfortunately, the least guarantee of getting the latest data. That means you will suffer from eventual consistency in 1 the most. Quorum or local quorum. What's local quorum? You see, you have multiple data centers. You can say local quorum. That means I, the application server, am in this data center. So I want to create a quorum only in my data center. The other data center can be replicated asynchronously. Local quorum. There's another one called each quorum, which essentially guarantees quorum in every single data center. You see, you have great powers. Please use them responsibly. Because this, the moment you do each quorum, your time taken for your write is going to slow down. The time taken for your read is going to be more. Why? Because it has to achieve quorum in all the replica nodes, in all the data centers, and the data centers could be thousands of kilometers or miles away. Finally, all. This is a paranoia level, paranoid level. This is something that you have a choice, but it is not advisable. Because in a large Cassandra cluster, failures are normal. This is the consistency level where you are not embracing failure. You are expecting that the cluster is always up and running. And that is an unfair expectation from any IT system. Failures will happen. And we already know when. Just before that important demonstration, when your boss stands by and you're hitting the enter key, you get the 500 server error. Exactly at that particular point in time, it's going to fail. Right? Murphy's Law, you know it. One very interesting aspect I want to bring forth here is there some sort of a relationship, some sort of a formula that you can apply to say that if this formula is true, any distributed masterless architecture will give me immediate consistency. What a brilliant articulation here. No, not by me. This is what the industry has created. Consider this situation. If the nodes written to plus the nodes read from, if the sum of this is greater than replication factor, you are guaranteed to get immediate consistency in any distributed masterless system. Let's take some numbers. If I write at consistency level 1 and I read from consistency level all, if my replication factor is 3, what do you think the sum is? Nodes written to is 1 and nodes read from is 3. 1 plus 3 is 4. 4 is greater than replication factor 3. If I want to write in quorum, 2 plus 2 is 4, greater than 3. If I write in all and read from 1, 3 plus 1 is 4, still greater than 3. You see this? This is the magic potion. This is the magic formula. And by the way, it has got nothing to do with Cassandra. Any distributed masterless system, if you pay the currency of time, you will get immediate consistency. Folks, this is the reason why masterless architecture perhaps is gaining popularity in the industry. Because without bringing in any third-party component, you can get all three strong attributes of Brewer's CAP theorem.